All right, this first example, we're going to use an identity to find the value of the expression. So we have the cosine of 2.9 times the secant of 2.9. So we're going to go up to our identities. We're working with cosine and secant. Notice the relationship between these two. They are inverses of each other. So I'm going to use the identity that the secant of an angle is 1 over the cosine of the angle. So I'm going to change this to 1 over the cosine of 2.9. I am reciprocating it. And then I still have the cosine of 2.9. I'm going to change this to a fraction. Notice what happens is this cosine of 2.9 and cosine of 2.9 are common factors, so they cancel out. And then we multiply across. 1 divided by 1 is 1. So that expression simplifies to 1. In this yellow box is the definition of a periodic function. A function f is a periodic if there exists a positive number, so that we have this equation. T is in the domain, and then you have a period. So let's talk about an example. So if I were to graph out the parent function of the sine, 1 revolution is 2 pi. To continue that pattern, you would add another 2 pi and continue that. So the period for a sine function, 1 revolution, is 2 pi or negative 2 pi. So what we can do is we can say that this sine of 9 pi over 4 does have coterminal angles that we can find the exact value. So we're going to find the coterminal angle to 9 pi over 4. So here would be pi over 4, and if we count around, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7, 8. This is equivalent to 2 pi. So there's 1 revolution, and you go a little bit more. These two are coterminal to each other. We know the ordered pair for pi over 4 on the unit circle is the square root of 2 over 2, square root of 2 over 2. The first value is your cosine value, and the second value is your sine value. So if we use this equation up above, the sine of pi over 4 plus 2 pi is equivalent to the sine of pi over 4. So if we use our value right there, what is the sine of pi over 4? This is exactly the square root of 2 over 2. Here's another example. The tangent of negative 5 pi over 4. So the tangent function has a period of not 2 pi, but pi. So 1 revolution is a distance of pi. So if I think about pi over 4, and I count pi over 4, but I go in the negative, so here would be negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4. So here would be negative 5 pi over 4. These two angles right here directly across are a distance of 4 pi over 4 or pi. So this is one revolution, one period from here to here. So we're going to go ahead and use our tangent of pi over 4 plus 4 pi over 4, which is one revolution, but we're going in the negative. So we're going to go ahead and put a negative there. So these are the same values as pi over 4. So let's review the ordered pair again from the previous example. This is the square root of 2 over 2, comma the square root of 2 over 2. So to find the tangent, we're going to use the quotient identity. We're going to take the sine over the cosine, which is 1. So the tangent of pi over 4 exactly is 1. So we're going to substitute that right into here. So negative 1 is the answer to the tangent of negative 5 pi over 4.